We talked about atomic tests. Now let's talk about managing test data for parallelization. This one is actually probably one of the toughest things to do because sometimes our applications are not testable. Again, I talked about having scenes and testability in our web applications, but managing test data basically just means that we don't want to be doing this kind of situation where we're hard coding test data. And again, sometimes it's not possible. Sometimes we are stuck with hard coded data, in which case we need to think of other solutions. But with hard coded test data, hard coding test data, the challenge is that, let's say you have a user and you're expecting to have that user in a certain state, and you try to run 2 tests in parallel or more tests in parallel, but let's just talk about 2, right? If one test is modifying the state of that user, and let's say it's changing how much this user is making, while the other test is expecting this user to be making that amount that was changed, you're going to get into problems, right? Because the second test was expecting something that the first test modified. And so hard-coded test data doesn't allow us to run in parallel because of this kind of situation whenever we have to manage state. So the ideal case is to avoid it as much as possible. Again, like I said, it's not always possible. It's a long exercise. Sometimes it's a lot of exploration and learning what your application can do, but it's certainly worth it. What I do recommend is just-in-time test data management. So that's basically kind of, Santosh kind of also hinted at it, is basically you are opening up your application or your test. You are using something like an API to create your user, providing whatever attributes that user needs. Then you're using your UI to perform the operations with that user, and then you're killing him at the end, or him or her at the end. Here's an example of that. So again, this is just pseudocode, but applicable to many of our applications these days. The more legacy applications, harder, but again, certainly worth exploring because we do want to run in parallel. So here, for example, we have our app API. We use our API to create a new user. And at this point, we start using our UI, right? We open up our login page and we log in with this new user that we just created. We can do our assertion in the UI, and then at the end, of course, deleting that user from the database so that we're cleaning it up. So that would just be an example of how we would combine API and UI together into a scenario where test data is not going to be a problem, because for this test case, this user will always be unique, and another test case will never rely on that user existing. So the third requirement of parallelization is autonomous tests. Now, luckily, I don't see this happening too often, but autonomous tests are, what I don't see happening too often is non-autonomous tests. But autonomous tests are those that are self-contained and isolated, meaning that if you run test 1 and test 2 should never rely on the outcome of test 1. Because what happens if test 1 fails? Then test 2 automatically fails. But test 2 doesn't fail because there's a bug in the application. It fails because test 1 failed and because test 2 was depending on it. So again, like I said, I don't see this happening too often nowadays, so it's good, but I do want to mention it because it is important. Some hints that you don't have autonomous tests is when you start doing stuff like depends, or I'm trying to remember in like C# what that annotation is. I think it's like, test order. There's a test order attribute. If you start having test order attributes in your automation, you know your tests are not autonomous, because it means that your tests have to run in some specific order in order to function correctly. So just avoid non-autonomous tests. And then the fourth and final one, and this one is interesting because it's like a double-edged sword. It's really easy to avoid if you know about it, which I'm telling you now. So hopefully none of you all use the static keyword in your automation, especially for creating a web driver, because what does the static keyword mean? It means that you're going to have a single instance of this driver in your memory space. And so when you start running 10 tests in parallel, one of them is going to use this exact driver to open a page. The other one will try to click on an element, and another one will try to type in a field, and all of them will be using the same exact driver, and funky stuff will start happening. You'll start getting a bunch of random exceptions. And so if you avoid this, your automation can pretty much run in parallel. But if you add this one keyword, for example, especially with your driver or any other object where state needs to be managed, you kill your parallelization like instantly. So that's why I say it's a double-edged sword. And I can actually show you guys a quick example of that. We can do that. You guys saw this framework running. And let me see if I can just, I'm just actually doing this on the fly. I didn't plan it, but let me see my base test. So here's my driver, right? You can see it's non-static, but what if we make it static? And then we rerun this automation right here and right now. Here's my 190 tests. Oh, I gotta save it. I think it saved it. We'll see if it passes. It didn't save it. Visual Studio didn't used to save automatically. I saw it did just save, but let's see what happens. But so yeah, basically just avoiding a static keyword. Of course, static keyword is okay with like immutable stuff like right strings and so on, but try to avoid it as much as you can. And then I have some bonus tips, but let's see if this automation, what is going on with it. Still running. Let's check source logs. We'll give it a moment to run. So the tests are passing, which is not good. I think it didn't save. Or I'm not in the right class. Let me see here. 1 second, sorry. Oh, it's got this finger thing, it's frozen. There we go. I think I was not in the right class. Oh, yeah, sorry, was in the wrong class. I broke another class. There we go. Sorry, it's being super slow. All right, cool. Let's give this another shot. May the demo gods be with me.
It's the curse of coding live, right?
Yeah, for sure. If I can't show you guys how my automation can fail intentionally, then you know I'm really good. Because if I can't break it intentionally, that's pretty awesome, right? So let's go see here. Oh, look, awesome. So you can see failures here happening. So let's see if this is finishing up. Yeah, see, so you can see here's a bunch of failures, right? Actually 135 failed and 55 passed. And what you'll see here is a bunch of random errors that don't make any sense. And that's a hint of static keyword abuse and improper parallelization, actually. So this one timed out after 5 seconds. This one unable to find another element. This one unable to find another element. This one is an unexpected error. You can see so many different errors, right? So that's a kind of a red flag. When I see this in like a client or someone's automation, I'm like, oh, you're probably having multi-threading issues. Okay, cool. Let me share the bonus tips while that runs. So 2 bonus tips, just again, in terms of achieving parallelization. Keep tests quick, because just remember that if we all have the power of parallelization these days. So our entire test suite will be as slow as the slowest test. So if we have a single test that's 20 minutes long and the rest of our tests are a minute, it doesn't matter if we can run 1,000 sessions in parallel, you will still have to wait for that 20-minute test to fail, to finish. So that's why it's good to keep them quick, right? If all of our tests are a minute and we can have as much parallelization as we want, our entire suite will never run slower than a minute, which is pretty awesome. And then also start parallelization early. This one is really key because a lot of us won't think about parallelization until later down the road, right? We have 100 or 1,000 tests in, and we're like, man, this automation is taking 8 hours or a whole night to execute. I need to figure out a way around it. And then we start trying to implement parallelization, but we introduce the static keyword in our driver. We now have a massive, insane refactoring effort to make our automation be able to run in parallel. I actually had that happen with a customer. I had to refactor their entire framework because their automation was taking like 24 hours to execute. And I tried to make it run in parallel, saw the static keyword, saw it all over the place, and I basically had to rewrite the entire framework. So, and this customer had like a team of 100 people working on this framework and running it. So you can imagine how many millions of dollars they spent on it in order for it to be refactored to be able to be more efficient. So that's why I say start early. Write 2 tests. As soon as you have 2 tests, try to make them run in parallel. It will be easier to overcome the challenges of making 2 tests run in parallel than it will be 1,000.